Hello everyone. Now we are starting very interesting concepts, that is graphs, right? Once you know the technique of using graphs for analyzing different physics problems, it is very interesting and you will find it very interesting, right? So here we are discussing position time graphs today, and again we are just comparing with whatever we have studied in 9th standard. So let's recall a graph like this. This is the position with respect to origin. This is the time. This is in seconds and this is in meters. So if you have a graph like this with a line parallel to the time axis, it shows that at 1 second, suppose the position is 4 meters here. At 2 seconds, the position is still the same, 4 meters. At 3 seconds, the position is still the same. So that means this shows that time is increasing, but the distance, the position remains the same. So you can say that here this shows the position of rest. So this is at rest. Right? Now if we are talking about the case when the body is moving as the time passes. So suppose this is the graph, this is the position, this is the time in seconds, and this is in meters. So if we take any 2 points here, let's take 2 points A, B, and take another point C. This is B, this is A, this is C. And this is suppose 1 second, this is 2 second, this is 3 second. Right, suppose this is 4, 6 meters, and this is 8 meters. Say for example, right? So we can mark that this 1 second is corresponding to 4 meters, 2 second is corresponding to 6 meters, and 3 second is corresponding to 8 meters, right? If I want to find the velocity between A and B, right? So velocity, you remember in 9th standard you had used this formula. This is what? Final position minus initial position. You can write this as xv minus xa upon time at B minus time at A. Right? So we are finding the velocity between A and B points. So this gives us x at B. X at B is 6. X at A is 4. Time at B is 2. Time at A is 1. So this gives us 2 meter per second. Similarly, if I want to find the velocity between V and BC, so this can be x at C, yani position at C minus position at B upon time at C minus time at B. Look at the graph. At B, at C, the position is 8. At B, the position is 6. At C, the time is 3. And at B, the time is 2. So this again gives us 2 meter per second. So you can conclude from here that this is a graph of uniform motion. That means here the velocity is same. So these are the 2 cases which we have already studied. Now let's consider that what does this, whatever we are calculating here, what does this mean? So if we are taking these 2 points A and B, let's enlarge this diagram. Enlarge this diagram like this. These are the 2 points A and B, right? And this is the position x. This is the time. So at B, how much is the position? 6. At A, how much is the position? 4. And at A, this is 1 and this is 2. What we are doing actually? What have we written? X2 means this point, right? x1 means this point. So what have we done? We have actually written x2 minus x1. If I mark this point as C, so we know that here BC will be x2 minus x1, and this we can write down delta x, and here AC is what? T2 minus T1, right? So this can be written as delta T here, right? So what have we done? For average velocity, if we consider this as triangle with angle theta, because this is a right triangle, right? So this we have written perpendicular upon base. This is what we have written actually, because you can write here x2 minus x1 upon t2 minus t1. So perpendicular upon base is what? This is tan theta. And I'll explain you, this tan theta is called as slope of anything. Suppose what we are considering this scale. This is horizontal. How much is the slope? 0. If we are increasing this, suppose this is the line, this is horizontal. If we are increasing this, right, what happens is we have this vertical distance traveled for the same, for this horizontal distance, and if we increase its slope, this is here. So for the particular horizontal distance, it has traveled how much? Vertical distance this much, right? For more slope, it has covered this vertical distance for this horizontal distance. So this way we know that this slope is related to the horizontal distance and the vertical distance, right? So a relation between vertical and horizontal distance is here x2 minus x1 upon t2 minus t1. So this gives us, this relation gives us the slope. So you can say here in short, the relation between vertical height and base gives slope. So that's why this is also called as tan theta, because tan theta is given by a relation, it gives us the relation between the vertical height and the base. I hope this is clear. So I am rubbing the board for this. Is that clear, everyone? So now only one more concept I will discuss in this particular video, average velocity. So this is the case of uniform motion. So when we are considering a non-uniform motion, what do we mean by non-uniform motion? We have studied in the previous video that in non-uniform motion, a body covers either unequal distances in equal interval of time or equal distances in unequal interval of time, right? So either equal distance in unequal interval or unequal distance in equal interval of time, right? Both ways it is true. So if a body is in non-uniform motion, so here we have to consider non-uniform motion. Then how can we understand this? Let's take an example. We all have our vehicles at home. When we start from our home, what happens is that suppose we have a car, right? It's standing at home. We take out the car. We start accelerating it. So it starts moving initially. So initially what happens is builds velocity and increases velocity. Why? Because we are applying accelerator. Then after we want to move for some uniform velocity. Then after some uniform velocity, we don't apply the accelerator. And then after we want to stop somewhere. Then what do? Brakes applied. Velocity decreases and then it stops. given in your NCERT also. If I draw this graph and I have to mark the intervals from NCERT, suppose we are considering that from 0 to 2, there was no motion, the preparations were done. So it started 2, 4, 6, 8, 10, 12, 14, 18, 20 and 22. So till here, I am marking it over here. This is 14, this is 12, this is 10, this is 8, this is 6, this is 4, and then I have to shift it here. And this is 2 over here, right? And for the position, I am marking it here. This is time in seconds. Right? So from here, initially, the body started from rest, and from 0 to 10 seconds, right? Here I'll have to mark these points again. 50, 100, 150, 200, 250, and 300 here. So from 0 to 10 seconds and then 10 to 18 seconds. They have given these intervals 0 to 10 and then 10 to 18 seconds and then different. So 0 to 10 seconds it is accelerated because the speed is increasing and the speed reaches around 50. So here it started. So this is a kind of curve, right? And then after, it had some uniform velocity. Uniform velocity is still 18 seconds. So 18 seconds it has covered around 250. Yeah. So this part will be a kind of straight line. And then after it started applying brakes. So the slope here will decrease and then the position will be like this. So let me explain this situation. This interval, this interval, this interval and this interval. So if you look at the position, when the when this car started from rest, so initially the speed is increasing, the velocity is increasing. In this case, it's a case of uniform velocity because you remember that for uniform motion, the graph was straight line. Right? So this part, if I mark these parts, this is O, this is A, this is B, this is C and this is D. Right? So if I mark these part, this shows your O to A part. Right? A to B part, no acceleration, uniform velocity. Right? B to C, velocity decreases and then it stops. Right? So this is showing B to C and C to D is rest. Right? So look at this beta. This is straight line uniform motion case. Right? So let's again recall, we have just discussed the concept of slope. Right? So slope shows more the slope, more is the velocity. We just calculated x t, v is x2 minus x1 upon t2 minus t1. Right? So this is slope. This is tan theta. We have just discussed it. So more the slope, more velocity, formed of very small straight line parts. So I can consider the slope. So if I consider the small slope, right? So this small slope is less here. Here it is more. Here it is more. Here it is more. So during OA, the slope is increasing. So this is accelerated motion. Slope increasing means velocity increasing, right? If we consider A to B, slope constant between A to B, straight line. So we can say that slope constant, velocity constant, therefore acceleration 0, right? If I consider B to C, here the slope was this, here the slope is less. How do we compare the slope? This is the slope, more slope. Now this is less slope, this is more, this is less. So this one BC slope is less. Again at non-uniform rate. So BC slope decreases. Therefore velocity decreases. Right? And finally here between C and D, the slope is 0. It is parallel to the time axis. So CD may, the slope is 0. So it is rest. I hope this diagram is clear, everyone. You will use these concepts to understand many other things over there. Right? Thank you. That's all for now.